Bonjour tout le monde. Well, hello friends and fielders as well. So as Paige mentioned, I'm Ali. I'm a developer advocate at the FileQueen Foundation, which works closely with Protocol Labs and IPFS. So I'm really psyched to be here in beautiful Paris and to chat, even though it's really hot, and to chat to you all about our vision here at Protocol Labs and the FileQueen Foundation for a truly open and democratic internet and web, and why we're building out some of the foundational tooling to do that. As well as take a brief look at what the future holds for Filecoin. So the timestamps, IPFS and Filecoin, some concepts, tech and tooling, and then I want to briefly touch on the future of Filecoin if I get a chance. Firstly though, a reminder on why we're doing all this. So I heard this quote up here a couple of months ago, conveniently in Paris also. I was listening to Juan Benet at a peer-to-peer meetup here. And this really struck me at the time because this is exactly why I'm in tech, and more specifically why I'm in Web3 as well. So it's one of the reasons I went into tech originally, because it's just how fundamentally that innovation and technological advancement can change and improve our human lives. And we really don't have to look back too far to see that, evidence of that. Like in the past 100 years alone, advances in healthcare, inventions such as the sewing machine and washing machine, the printing press, onto the more modern era of computers and the internet and mobile phones, obviously, they've drastically improved the lives of millions. They've paved the way for major social changes, and with a rethinking of value and role of people in society as well. So, for example, those household automations gave freedom and empowerment to women across the world and changed the landscape in general for the better. And the internet has given mass accessibility to education and ideas, as well as enabling collaboration on a global scale. And I don't know where we would have been in the pandemic without it, quite frankly. So to me, the real goal is not tech in and of itself, but the real goal is people and improving the human condition by leveraging tech and other scientific breakthroughs to do so. So this is also why it's really essential that we make sure we are building them right. So just before I dig into the tech, Filecoin and IPFS are actually part of a larger organisation and ecosystem. Both of these projects were originally incubated by Protocol Labs, which is our research and development lab. It's a fully distributed open source R&D organisation. It was founded by Juan Benet in 2013. It builds protocols, tools and services and aims to help radically improve the internet and drive breakthroughs in computing that can move us and humanity forward. And this is a genuine mission shared throughout the organisation, as I kind of mentioned before. So IPFS and Filecoin are two of the projects that were originally incubated by Protocol Labs, as I mentioned, and Filecoin Foundation is the government's body behind the Filecoin decentralised storage network. So as you would all know, data is an essential part of our daily lives. Not surprisingly, also a super fast growing field in Web3, because enabling distributed storage mechanisms also enables so many new applications and use cases to be built out with more permanence, with trustlessness, and with more resilient outcomes, and censorship resistant qualities as well. We really don't have to look far to see how influential and important data and the internet have become to humanity. So the problem is, if we look at current models of data storage and sharing, they mostly fit in a centralisation model. So there's only a few companies out there offering storage, they're all centralised, and they have access and rights to our data via our social media or web profiles. Like, if you're not paying for it, you are the product, as we all know. So this leads to several issues, and they're both social and engineering issues as well. So the first one's a resilience engineering challenge. Central models create central points of failure. If a central server goes down, whole services which we rely on daily also go down. So Twitch, YouTube, payment or other essential services go down with central models. And obviously this is happening everywhere, and these central services are even trying to create these multi and hybrid cloud models now, which try and combat that. So this is a true business problem. So another problem is the lack of security and ownership of our data. Am I on the right? Yep, cool. Central models create these attack vectors for data harvesting. So this costs individuals and businesses dearly, both in financial and trust terms. It also poses a censorship and misuse threat. We've seen plenty of stories around what can happen with large sets of data and how countries and vested interests can leverage that data to sway voters, to censor people's access to information, or to otherwise create societal mistrust and problems. So other big issues for users are inbuilt censorship and a lack of portability around their own data. Central models have the power to decide who is allowed to store content with them, under what circumstances, and how. So this leads to vendor lock-in and a complete lack of data sovereignty. So once you store your data somewhere, it's very difficult to move it. And you're then at the whim of that centralised entity's pricing model. A good example being the recent Patreon move, which changed its pricing an astronomical amount for creators, and they really have nowhere to go and can't take their followers. And these issues really lead to the question, why aren't we designing the web for the autonomy and resilience we need in the first place? And how do we get to a world that has resilient, performant, scalable, censor-resistant, and open data? So this is exactly the kind of problems we're working on solving at IPFS and Filecoin. So let's get into the tech. I'm going to start with IPFS, or cue the Star Wars theme, please, the Interplanetary File System. This isn't just a meme name, though, because as a distributed peer-to-peer network for files and folders, it was designed to be able to work even when the network is between planets. So let's say you signed up for the Mars Colony program, you're living happily on Mars, maybe it takes you an hour or so to request a file from Earth that you need, but if someone else on Mars already has that file, then that person can serve you that content instantly instead. So maybe you're thinking right now, well, this is just a fancy name for a peer-to-peer network, but there's real gravity, pun intended, in what it does, because IPFS is distributed by design. It has no central authority servers, it's designed to be offline first for resilient, and it uses a really unique and upgradable standard for addressing content. And this is the unique part of IPFS, because rather than using methods we might be familiar with for storing and accessing content, so location paths that point to a particular HTTP address, which is what we do every day on the internet, and where the content could fairly easily change from day to day, IPFS uses content addressing. So this means that not only can you be sure when accessing an IPFS content ID that you'll receive the exact same piece of content every time, but you also don't care where that data comes from. So this idea was kind of wild to me when I first started looking into IPFS and Filecoin, because it's really such a mind shift from Web 2 world we're all kind of accustomed to. And it's also super elegant in its simplicity as well. So just shifting the focus from a location-based address to a content-based ID opens up the web to massively distributed storage solutions and trustless data verification methods as well. So how do we make these? In order to create a content address, which you can think of like a cryptographic fingerprint, we use a cryptographic hash function to create a content identifier, or CID for short, for each piece of information that we want to put on the network. So this means that every piece of content has its own unique CID of the same size, regardless of the amount of content it represents, and importantly, this CID can be reproduced anytime from the original content, so we can always verify that the content we've been given is exactly what we asked for. And that verification is also an important point, because you create trustless peer-to-peer systems then. So also, if I create a CID of my favourite meme, for example, and then change one pixel of that image, I'll have a different CID. And just to quickly note, here as an aside as well, this content addressing works for all content, including, for example, folders. It's not just limited to like a JPEG. We can even represent a full file system using a content addressing structure, and we even store the entirety of Wikipedia on IPFS back in 2017 when Turkey's authorities blocked this website from being served in the country. So pretty wild. And this is an illustration of that and how our file structure would be represented. This is a content addressing graph, or what we call a Merkle DAG, directed acyclic graph for the nerds out there. And the main point is these Merkle DAGs are what allow IPFS to move from location-based addressing to content addressing in a single step. It just replaces locations with the root CID of their content. The subpaths stay the same. This is an example of how this works. Let's say we wanted to copy biscuit that's his name by the way, the corgi, to the folder of the second user. Actually, we don't really need to copy the file because 2 copies of the same content have the same identifier. So to IPFS, they're the same thing. So this is called deduplication. Instead, we just have to modify the containing folder to reference the content and then propagate the new content IDs of that folder up through to the root CID. And this is pretty neat because, like I've said earlier, the fact that our CID will always represent exactly the same piece of information, unlike a location, means we're retaining the verifiability of that piece of data as well as unlocking decentralization and resilience through distribution. Okay, so you can make and represent a bunch of content. Great, let's move on to how we retrieve it. We do this with a peer-to-peer network where each peer in the network also has a unique identifier called a peer ID, which is again, of course, linked to a cryptographic identity and which allows each peer to communicate securely through an encrypted channel. And this looks something like the Star Wars path tracing mission diagram above. And in order for peers to be able to discover each other and the network transports they support, we then use a distributed hash table, or DHT. So if you're a developer, you've likely heard of a hash table, so the distributed version isn't too different apart from the need for multiple peers to maintain it. In simple terms though, a DHT is kind of like a phone book, except that everyone helps to keep those phone numbers or addresses updated. So in order to get the value associated with a key, in this case the content ID, a peer asks the other peers in the network who has this row. It's a bit more efficient than a general broadcast, but I'll let you dig into the details of that if you're interested. But the main thing to understand here is all of this protocol and networking logic, designed by people much smarter than me, is what makes IPFS a really important and valuable protocol. And not just for Web3 either, but for general tech use cases and specifically for the web in general, as well as for anyone who wants to serve or retrieve content, which is everyone. And that's because it enables distribution at scale, it provides that verifiability, and it's trustless. So how do we ensure the persistence and permanence of this data though? So you have to run nodes where you store this data. So why would random people help store your digital content for no reason? Maybe if they like you, they might, or they like your content, they might. But generally, despite the usually good intentions of a community, less popular pieces of content will probably stop being hosted and will no longer be able to be retrievable. So one solution is to pay a pinning service to host our data for us. Unfortunately though, relying on this kind of creates another centralization issue, and we end up with the same resilience problem we kind of started the process with. So what's the solution? For those of you playing at home, yep, this is where Filecoin comes in. So Filecoin's a decentralised storage system designed to leverage a crypto-economic incentive model together with cryptographic proofs in order to ensure data is stored persistently, as well as highly reliably and verifiably across a distributed network. So Filecoin currently has over 4,000, or approximately 4,000 storage providers globally, and it makes up 1% of the world's current data storage capacity, which is pretty cool for a protocol that only launched at the end of 2020 or 2019. It's the largest decentralized storage solution as well. So it's architecture and designed to leverage these crypto-economic incentives, as I mentioned. And its use of cryptographic proofs also enables smart contract-based permanence too. So it means that it's designed to be as permanent as you, the data owner, want it to be. So whether that permanence requirement is 500 or years or 5 minutes, you have control over that time frame. And it's also designed to be hyper-competitive on pricing due to the distributed nature of the storage and the economic reward model and how those create, because you have peers like bidding for your data basically, and then you have storage providers that want that data. You put up that you want to store this and they all bid basically, so you create a market model, which means that it's going to be cheap forever as well. Or work at least like a market structure should. The network also has internet scale capacity, so about 18 million terabytes, 18 exabytes, a really big number of storage capacity at the moment. So this is enough capacity for a lot of data. Anyway, I've gotten carried away. Let's have a look at how it works in practice. To make all this work, Filecoin uses storage deals, like I just mentioned, which include two main consensus mechanisms that ensure both rewards for good actors in the system and penalties for bad actors. So when you make a deal with one or more storage providers to store your data, the provider generates a proof of replication, which is our first consensus mechanism, and this proves that the storage provider is storing a unique copy of original data. Over time, providers must prove that they still have random subsets of this client data, and they create a proof of space-time, and this happens daily. So anyone at any time can also check this proof of space-time as well to make sure the storage provider is doing what they say and storing your data. So this proof makes up the mechanism by which our storage providers are incrementally rewarded with Filecoin. And since they must stake that Filecoin as collateral to join the network, if they don't provide these proofs, they are penalised. And this dissuades people from undesirable activity on the network. So when the storage deal comes to an end, a user can opt to let it expire or renew the deal. If they opt for renewal, then providers will bid to host this data content, again, like creating this efficient market for pricing. So this is what builds in not just data permanence, but also data timeframe sovereignty. So you decide if you want to store it for 5 minutes or 500 years. You also have sovereignty over how many copies of that data you want to have and on what providers. So not only does this deal-making structure allow for an efficient market, but it opens the door for you to comply with regulations like GDPR. And there's a growing number of tools in the ecosystem, such as Murmuration's Bitscreen, that allows you to filter these deals, as well as a really exciting project we'll talk about later that will allow this use case too. And there's lots of opportunity to build toolings in this space that help with all sorts of things. So while IPFS and Filecoin are separate projects, they're designed to be complementary. So IPFS offers this content verifiability, faster and flexible retrievals, and Filecoin offers verifiable data persistence at internet scale, so that even if your computer or your favourite IPFS pinning service were to go away, that content persists. Just as a side point here, IPFS is storage layer agnostic, so that means that you can combine it with the storage layer of your choice. That could be Filecoin, obviously I think that's a great option, but you can also store your data with a centralised cloud storage provider or another storage, decentralised storage solution. So I'll just can I just get a time check? Where am I up to? Okay, thank you. All right, I'll quickly run through these. The future of Filecoin. As I mentioned earlier, it's only been just over 15 months since we launched the network, and we've achieved a great deal and come a really long way towards creating an internet-scale decentralised storage network. Obviously, there is still a lot more to do, and that looks something like this. So currently Filecoin enables verifiable storage at scale, but accessing and retrieving that data isn't always simple, and it's not always easy to create programmable applications on top of this data or to do computation either. So these are all technology vectors that make up the future of this space. There's also some current projects that are really working towards the social aspect of Filecoin as well. And I know some of these people are going to be speaking today, so I won't talk too much on them, but just so you get a brief overview. Firstly, FileQueen Green, amazing project. I know they're talking, so I'm just... They're here too. I won't talk too much about them. I'll let them explain for themselves. There's also the FileQueen Foundation for the Decentralised Web, which is I love it. Got some excitement in the room. So this is a charity organisation. Again, they're going to be talking today about what they do, so I will let them speak for themselves. But just so you can find it, and I can post these slides up later as well. There's also FileQueen Plus, aimed at incentivising storage providers to store valuable data sets on Filecoin. There's social good use cases, which we're definitely going to hear about as well. This is the FileQueen Saturn is the retrieval piece. We're creating a decentralised CDN, so awesome. And the Filecoin virtual machine, which is one of my favourites, is going to add programmability to the Filecoin network, and we're going to talk about that one later as well. So thank you all. That is pretty much it from me.